students, welcome back. This is Torres, Elbow Bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please send me an email. So lucky you, you get to hear my voice for another lecture. But the best part is we will be preparing and interpreting regression output. Yay! So in the last few lectures, we have emphasized things like plotting points, interpreting the equation of a line, looking at scatterplots, where the independent variable is and where the dependent variable is. And in the last lecture, we discussed the line of best fit. The line of best fit is created in a way to minimize the residuals as much as possible. Since the line of best fit is a line, then we can describe that line using the equation of a line. So here we have y, and here they just happen to have y hat, equals 17,067 minus 0.0623x. And here is our figure that matches this equation. If you recall, for whatever reason, in stats, we don't use y equals mx plus b. We like to use y equals b plus mx. So here is our b. The 17,067 is our b, our y-intercept. And it intercepts way up here, off the graph, right? It keeps going off the graph all the way out here. And then we can show that it's a negative trending line by having a negative in front of the slope. And this is confirmed here. This line is a negative line. And the slope tells us how much the rise is changing over the run. So for every 1 unit increase in the independent variable, the dependent variable will decrease by this amount, a little bit more than 6/10, right? And we know that it's decreasing, first of all, because we have a negative line, but then two, we get the same information with this sign right here, the sign in front of the slope. Okay, so just looking at the equation of a line, we should be able to have an understanding that this line is going downwards. It intersects here at 17,067. So if you're looking at other points relative to that, you can use that information if needed, but it should give you a really good idea of what to expect in this line. So what we're going to do today is we're actually going to be using StatCrunch to look at some independent and dependent variables and interpreting the output. Okay, so here I am in StatCrunch, and I have uploaded some data. This data has an ID number of the participant, community type, meaning like where they live, gender, and it also has reading scores for 8th grade, reading scores for 10th grade, reading scores for 10th grade math, and reading scores for social studies in 10th grade. So what we have is 1 8th grade variable for reading and 3 10th grade variables, 1 for reading, 1 for math, and 1 for social studies. And we want to do a comparison. The first thing I need to be able to do is check to see that my data is normal. So I'm going to go ahead and run my data, my summary stats for all of the columns. I want to make sure that everything is normal, and I'm going to pick my quantitative variables. And if you recall, I'm going to go ahead and get the count, the mean, the standard deviation, the median, the min, and the max. Might as well get Q1, Q3, IQR, skewness, kurtosis, and mode. And I'm going to go ahead and compute that. All right, so here are my summary stats. Let's go through them one by one. Okay, so here I have reading. It looks like there's 499 students in this data set. The mean, 56.03, is right about the same as the median, which is 56.44. The skewness is slightly negative, so that means that we have a very slight left skew. But the skewness is within the acceptable range of positive and -1, and the kurtosis is also within the range between positive and -3. Achievement for reading in 8th grade is normal. Let's look at 10th grade. 10th grade, I've got a mean of 56.1 and a median of 57.7, so the median is a little bit less. Our skewness is negative 0.5, which is just a little bit less, but it is within the acceptable range of positive and negative 1, and our kurtosis is also within the range of positive and negative 3. For math, we've got the mean is 56.9 and the median is 57.21. It's showing that it's slightly negatively skewed, but it's still within the range of positive and negative 1, and the kurtosis is also within the range of positive and negative 3. And finally, social studies, we've got the mean 56.23, and this is 55.8. We have the skewness is positive 0.8, which is within the range of positive and negative 1, and the kurtosis is 2.66, and that also is within the range of positive and negative 3. Okay, great. So all our numerical values check out. Let's take a look at the figures. So let's start with the histogram. So I'm going to go to Graph, Histogram, and I'm going to go ahead and pick all of my histograms at once. Might as well just get them all out of the way. I'm going to go ahead and do my overlay distribution. I love to mark the mean and the median and go ahead and compute. This is reading achievement, 8th grade. This looks really nice. Mean and the median right close to the center. The mean is just a little bit less. That's why we got that left skew in the skewness number, but looks really nice. This has the shape of a normal distribution. This is reading 10th grade. You can see this is a lot more skewed than the last one. The mean and the median are still in the kind of in the middle, but the mean is slightly to the left of the median, and so this was giving us that larger skewness number. But because the skewness said, here it is, that it was still, we had a skewness of negative 0.55, it's still within the acceptable range. We're going to go ahead and go with that. Okay, here's another one. This looks really nice. The mean and the median are in the middle. We've got a little bit of a left skew over here, but nothing significant. It's just a little bit unbalanced. Again, the skewness number here said it was within the acceptable limits, so that's enough evidence for us to proceed. And finally, this one was the one positive skew that we had. Here we have the mean just slightly to the right of the median, and it looks like this outlier out here is what's kind of messing the whole thing up, but otherwise it would look pretty normal. If we look at the output for the skewness and here, we see that this does have a pretty significant positive skew, but it's still within normal limits. So this is normal enough. Okay, remember, we're looking for the data to be normal enough to have some evidence that the empirical rule applies. Okay, so according to the histograms, we're still looking good. Let's check the box plots. To make the box plots, we go to Graph, Box Plot, and we go ahead and select our variables, same ones we've been selecting, our quantitative variables. And I like to draw them horizontally. I like to mark the mean and the median, and I go ahead and compute. Boom. Okie dokie. So this is going from bottom up. So this is reading 8th grade. We've got the mean and the median approximately in the center of the H spread, and the tails are not really of equal length. The left tail is just a little bit longer, which also verifies that left skew, but we've already checked the skewness here and we've decided that it fits. Okay, awesome. I'm gonna move this up here. Reading 10th grade. Reading in 10th grade has the mean and the median still in the middle of the H spread, more or less. The left tail is longer than the right tail. So again, that verifies that we have a left skew, but it's not skewed to the point where the data cannot be used. Here for math, we've got an outlier down here. So this number down here is pretty different than the majority of our data. If we were to exclude that number, we see that the mean and the median are in the middle of the H-spread, and the tails aren't too different. I mean, the left tail is definitely a little bit longer. Finally, for social studies achievement 10th grade, we've got this outlier all the way out here, which is the one that's really causing that positive skew. But looking at the skewness value, we're still within the acceptable range of positive and -1. The whiskers are approximately equal length. The left one is just a little bit longer because we're excluding that outlier. So at this point, everything looks normal. So at this point, we have the numerical check, which suggests that the data is normal. We have the histograms, which suggest that the data is normal. And we have the box plots that also suggest that the data is normal. So it looks like we can proceed with our regression. Everything's normal. We can work with any of these and it will be fine. So we just checked normality, which is essential when working with data and trying to make inferences about the population. And we have determined that all our data is normal and we can proceed. So we're going to go ahead and do a regression, which is just a study of an independent variable versus a dependent variable where a line of best fit is created and the output gives you information about the slope, the y-intercept, etc. Let's first start by just comparing reading 8th grade versus reading 10th grade. To make my regression, I'm actually going to go to stats and then go down to where it says regression. And like I said, we always work with linear regressions in this course. So I'm going to go ahead and click on simple linear, and it gives me some options here. We have to decide which one is going to be my independent variable because the X variable is the same as the independent variable. So in this situation where we have 8th grade reading and 10th grade reading, 8th grade came before 10th grade. So we want to know if how well a student read in 8th grade will affect how well they will read in 10th grade. So I'm going to go ahead and decide that my reading 8th grade is my independent variable, and I want to see if there's a relationship with my dependent variable achievement reading 10th grade. I think that's all I have to do with this at this point. Yes, so I'm going to go ahead and compute. Okay, so this first output gives you information about what you selected. Notice at the top here it says dependent variable achievement reading 10th grade. So that's what's going to be on the y-axis. That makes sense. My independent variable will be on the x-axis, and that is reading achievement 8th. The way this is displayed, it's asking the question, will how well a student performed on a test in 8th grade affect how well they will perform in 10th grade? I can't do that backwards. I can't say how well someone reads in 10th grade affect how well they read in 8th grade because you can't go backwards. So for something that has like a before and after, it makes it really easy because you know what came before and you know what came after. It gives you the correlation coefficient here, which is 0.75. We're going to get to that in a minute. Remember back to correlation coefficient, the strength of the scatterplot when we're describing it. And then here it has information about the slope and the intercept. The rest of the stuff you can just ignore. We don't go into statistical testing using regression in this course. So it says the slope is 0.708. So we're just going to go ahead and say just 0.7. And the y-intercept is 16.37. Okay, great. And then if I click at the bottom down here, I have the scatter plot, and here's my regression line. We see that it's a positive line, right? It's linear. And here are all the points that created my scatter plot. Looks nice. Notice here, see how we have all these people that topped out here? There must be a ceiling effect where you can't get higher than the 70 or something. That must be the highest you can get. So that's interesting that you would have these lines. Okay, so we have our numerical information. We have our scatter plot, And we know that our data is normally distributed. So we've gone ahead and done all our calculations. So what I want to do next is show you how we would write this up. So here is our information. And I took out a lot of the stuff that we didn't need. Take this out too. Actually, we don't need any of this stuff. This is all extra stuff that we don't need. So here's our information. My dependent variable was reading achievement 10th grade. My independent variable was reading achievement 8th grade. And I have the line. If you notice here, let's see if I can make this a little bit bigger. Look at that. It's our equation of a line. It has the y-intercept right here, here. It's got the slope here. Reading achievement 8th grade is our independent variable, or the x, and reading achievement 10th grade, dependent variable, or the y. So this looks really good. So let's go ahead and just write a little paragraph up about this so that you can see what this would look like if you were to go ahead and if you were to having to write this up. Okay, so I'm going to go ahead and write this for you. Okay, so here I have gone ahead and just written a couple paragraphs explaining what's happening in the Scatterplot and in our information. So I just wrote in the first paragraph, very short paragraph, normality was verified using numerical and visual methods. So that's telling the reader that we checked the distribution of the data using both the numerical output and we also used visual methods. And we could have put histogram and box plot if we wanted to, but I just wrote visual methods. Both the independent variable reading achievement 8th grade and the dependent variable reading achievement 10th grade can be considered to have a normal distribution. So in that sentence, I'm telling the reader what my independent variable is and what my dependent variable is and what the final result was of the test that we did to verify normality. The next paragraph says, a scatterplot was created to evaluate the relationship between the independent and dependent variables. So it's just saying, why did we verify that those variables were normal? Like, what was the point? And we're just basically saying we're looking to see if there is a relationship between the two. The scatterplot showed that there was a positive, moderately strong, r equals 0.75 linear relationship between the two variables. So that sentence is explaining the scatterplot, right? It's talking about the shape, which is linear. It's talking about the trend, which is positive. And it's also talking about the strength. And for the strength, I went ahead and used the correlation coefficient that I got from up here. Correlation coefficient, 0.75 is pretty strong. Doesn't look very strong here, but this number, the biggest it can get is 1 whole. So this is a pretty strong correlation. So I put that here. So with those three things, I'm able to describe my scatterplot. Finally, I state the equation of a line, which is just what we have here. So the equation of a line for statistics is usually stated as y equals b plus mx. Here we have the y, which is the dependent variable, reading achievement 10th grade. We have that equal to the y-intercept, which is 16.3. We also have the information about the slope, which is positive 0.71 if we wanted to round it, times the independent variable, reading achievement 8th grade. So I've gone ahead and just cut pasted that here. So the equation of a line of best fit, I put the equation here, suggests that for every 1 point increase, that should be in a student's reading ability, typo, in 8th grade, it can be expected that they will increase their reading score on a 10th grade test by approximately 0.71 points. And this is on average. This prediction is coming from the line of best fit. It's saying this fits most of the data, so we can use this averaged out line to give us information about students that we have not tested, the unknown population. Let's try one more. Using the same data, this time let's see if there is a relationship between a student's ability to read and their achievement in social studies. So we're going to go back to stats, regression, simple linear. Then our independent variable is going to be reading, and our dependent variable is going to be social studies, because we want to know how well somebody read affect how well they would perform in social studies. We're just seeing if there's a relationship. Okay, we can't say anything for sure, just looking for a relationship. And I'm going to go ahead and hit compute. And here are my results. For this, I've got dependent variable is social studies, yes. Independent variable reading, yes. It's got my equation of a line. It's also got my correlation coefficient, and it also puts down the slope and the y-intercept again here, but you can also, it's just giving us the same information here. Okay, let's look at our scatter plot. All right, so this is a little bit, it starts off being more blown out and then it seems to converge later, but it's still looking like a positive trend, right? It's linear because it's always linear, and this looks okay. This looks moderately strong. We can check how strong it is by looking at the correlation coefficient, which is 0.603. It's not as strong a relationship as it was between the 8th grade reading and 10th grade reading, but it's still a pretty good correlation. So let's go ahead and write this up too. Okay, let's see what I've got here. So here I wrote another couple paragraphs to summarize what we've done. It says, normality tests were conducted to determine if the variables had the approximate shape of a normal distribution. The numerical values, the histograms, and the box plots all confirm that the distribution can be considered normal. Actually, I'm going to change that confirm that both distributions can be considered normal. A scatterplot was created to evaluate a possible relationship between the independent variable reading achievement 10th grade, which is the x-axis here, see reading achievement 10th grade, and the dependent variable social studies achievement 10th grade. The scatterplot showed a linear positive trend of moderate strength. So here I described the scatterplot. The equation of the regression line, remember regression line is just another way of saying line of best fit. It's the exact same thing. I put down the equation of a line that I got from my output. Suggests that for every 1 point increase on the reading exam, there will be a 0.70 point increase in social study exam scores. And this is on average. So this is how you would summarize it. We have the 3 elements that are necessary in order to describe a scatterplot, which are shape, linear, trend, in this case positive, and strength, in this case moderately strong, 0.6, not as strong as the last one, but still pretty strong. That describes the scatterplot. And then we also explain what the meaning of the equation of the line for the line of best fit is. So what's the big idea? Today's big idea is that the line of best fit is the line which is created by minimizing the residuals, and it can describe the trend of the data. The equation that describes the line of best fit can be interpreted to describe the scenario in context. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course, okay? This is your teacher, Tora, saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!